more minutes here, try to wrap up as many of these as possible within that time we have. Okay, for you. All right, I'm going to show you answers for numbers 1 and 2. So let's compare. There you go. Take a look at what you've got. Take a look at what I've got. So you almost have it perfectly right. You did 4n minus. No, you did it perfectly right. Yeah, no, there's zero issue. That's perfect. Yeah. The parentheses, the dot, and all that stuff, no problem. It's good communication for sure. Okay, so as is typical, now's an opportunity for you all to look at what I have, look at what you have, ask a question. Yeah.
I don't understand what
Okay. So, are you wanting me just to kind of explain through you didn't really ask a question. Are you wanting me to? Okay. So I didn't know if there was something more specific, but I can go over what I did. So my first thing, the honest truth is really, really simple. When I did this, I did it exactly the way that I would ask you guys to think about it as well. When I first did this, I thought to myself, oh, this is one of those situations where one of the two people gets a head start, right? And so I drew this picture over here on the left. I drew it so that Billy gets the head start and Amy does not. So can you see how that's illustrated there? Billy jumped out ahead while Amy was waiting or whatever. He got a head start, right? Then I labeled those with DB and DA to signify distance of Billy and distance of Amy. Does anybody know how I figured out this 450-foot head start? How do I know it's 450? What did I do?
90 seconds.
90 seconds. And 5 feet. 5 feet per second. 5 times 90. It's a 450-foot head start. That's exactly right. So I did distance equals rate times time to figure out that head start. And then the next step is always the challenging step. We need to take that picture and we need to think of something like an equation that's true. So what I said was, I'll tell you what, I'll use some colors. Hopefully this will make sense. I basically, my way of thinking about this was this blue part plus this red part would equal this purple part. Red plus blue would equal purple. Does that make sense? little part plus other little part equals whole thing. Again, I'm not asking you to memorize anything because I think the worst thing we can do here is just memorize stuff. What I'm asking you to think of is, and I mean, it goes right to Mason's question or his statement. Does what I've done so far make logical sense? I'm trying to build logical strength in you, not just, I memorized a formula. That doesn't have a lot of meaning necessarily. Yeah.
How did you get 5T?
I'll get there in a second. So far, Mason, does this make sense? Let me use some more colors. Does this part make sense? If I say blue plus red equals purple, do you see how they go together? The blue is DB, the red is the head start, and the purple is the full distance of Amy. Does that make sense? Okay, so then Mason, how I got the 5T and the 8T, because they're similar, is I looked at distance, and I remembered that distance is equal to rate times time. And then I had to go back and look at the paragraph and see that the rate of Billy, the rate of Billy is 5 feet per second. So if distance equals rate times time, and Billy's rate is 5, then distance of Billy would have to be 5t. And that also means then that the distance of Amy would have to be her rate, which was 8, times time. That's where I got the 8t.
Okay.
I just replaced d with rt. Kind of a substitution, really. From there, I subtracted the 5t and then divided by 3 and got 150. For you guys at this point, I know you know how to do that, for sure. Thank you, Mason, for the question. Any other follow-ups or thoughts on 1 or 2? Okay, so here's 3 and 4. So number 3, I just put my answers in a box. So I think number 3 is 4x y to the 4th root 3x. Yeah, that looks good. I think number 3 is good up there. And number 4, let's see here. And then 10x over y to the 9th. Yup. 80x to the 14y cubed over 5y to the 9th. Yeah, that all looks good. I think that's right. 16x to the 14th over y to the side. I think both are good. So again, as you're comparing and looking at what you've got, hopefully they're the same. But if they're not, let's do a little analysis and figure it out. Yeah. On which one? 4, sure. So let me do a little zoom here. Maybe it'll be a little easier to see and kind of compare. So here were my thoughts. And then there is no one right way to do this one. Everything just has to be logical. So here was my first thought. I looked at this y to the negative 9th, and anytime a base has a negative exponent, what could or should we do with it? Flip it. So if it's in the top, flip it down. If it's in the bottom, flip it up. So my first thought was, I will take that y to the negative 9 and I'll flip it down. That was my first thought. That make sense? Okay, that was the first fraction. Second fraction, I noticed all this stuff up in the numerator, and I thought, well, doesn't this mean that cubed applies to all 3 factors? So here's what I did. I said 2 cubed, x cubed cubed is really x to the 9th, and then y to the 1st cubed is really y cubed. So I applied that cubed to each of those factors. And then down here, I have a 5. What's x to the 0?
1.
So 5 times 1, I could put the times 1, or I could just leave it as a 5, right? Because 5 times 1 is 5. That's a fairly trivial step. For my next step, I noticed that x to the 8 over x to the 3, that's the same base, right? So if you're dividing like bases, what do you do with your exponents? So I subtracted. So I got 10x to the 8 minus 3, which is 5, over y to the 9th. Notice I'm not saying step 1 is this, step 2 is that. I'm saying I noticed this and I noticed that. I'm trying to just be logical as I approach this. And can you tell I'm doing it in a slightly different way than what I did before?
Yeah.
Slightly different. I mean, it's very similar, but it's slightly different. So then over here, of course, 2 cubed is 8. And then I still have the 5 down there. Next thing, I don't know. I'll just do it different just to be different. Do you see how the 10 and the 5 would cancel out to be a 2 and a 1? I could have done that right here, let's just say. So then as I multiply, I would do 2 times 8. So that's 16. And then what about x to the 5 times x to the 9? What's that? X to the 14, right? You add your exponents there. And then I've got y cubed there. And then y to the 9 times 1 is just y to the 9. And then my final step would be to recognize that I've got a y in the numerator and a y in the denominator. And if you're dividing like bases again, what do? Subtract. Yep. So this, that's right. So it's going to be 16x to the 14 times y to the 3 minus 9. It's negative 6. And then my final step here would be to say, well, a negative exponent really means to take the base and do what? And now this time it's going to flip down, right? So it'd be y to the 6th. Of course, getting me to the exact same answer. But you can see I took a slightly different path, right? So please don't think of these as, gosh, if I could just memorize what to do, I'm good. You just need to know a couple of basic principles and then just notice things that are logical that you can attack and go with that. It's very possible that like the 4 of you could have 4 different paths and all get the same answer. So possible. So don't feel like you need to memorize stuff other than those basic principles of when do I add, when do I subtract, when do I multiply, that kind of thing, and you'll be fine. You'll be fine. Yeah.
Even y to the 9th even 1, that works. Why is that then y to the 6th?
So I think I see what you're looking at. I've got y to the 9th times 1. Is that what you're getting at?
Yeah.
You said I'm quoting you, you said you have y to the 9th.
Then why is that y to the 6th?
So here's your next step. Isn't y to the 9th times 1 just y to the 9th?
Yeah, and then, okay.
And then I subtracted those. Oh, that's not going to work very well. I subtracted those exponents. I got y to the negative 6th, which I then flipped down to be y to the positive 6th. Okay. Other questions? Can I make the suggestion for like the 20th time? Here, let me paint the picture for you. It's Thursday afternoon. And you're thinking, oh yeah, I've got that DMR quiz tomorrow. Man, that one on the exponents, that one about Amy and Billy, those are tough for me. Well, I'll probably just fail the DMR tomorrow. Or, what could you do?
Go through your packet.
You could go back through your packet and this video will be posted. And you'll be able to hear me talking about this right now. And you'll be able to say, oh, that's right, I needed to subtract the exponents there. And, oh, Billy got the head start. That's what I was forgetting. And you could get one more touch, one more look at it, one more practice with it. And that way, when you see that DMR on Friday, you're like, duh, Billy, you got the head start. I know it's coming. Have you guys, hey, listen. Have you figured out that the DMR quiz on Friday is indistinguishable from our DMR practices other than maybe a few numbers have changed? Like, they're the same. I could hold the DMR quiz up right next to this, and you would not be able to tell which one is which unless I told you. So there should be no mystery. I get it. Sometimes we make little mistakes. But there should not be a mystery as to what you're going to be assessed on. No mystery intended at all. So I hope you'll take that to heart and do a great job. Okay? We'll practice again tomorrow for sure. Okay, so we got a couple things we're going to do here. So if you would, flip over in your packet, and we are going to, again, try to approach things logically, and we'll get a few examples in. What do I got here? I've got 4 of them. We'll do some of them. We do have our factoring quiz today. And the cool thing is, a big part of what we're going to do today is factoring. So this is going to reinforce, hopefully, really well for your quiz. So, I am going to attempt to appeal to your logic here. Okay, I'm not going to try to get you to memorize stuff. I want to appeal to your logic, and I want to look at something called the zero factor property. Zero factor property. So here is my proposition to you. If A times B equals 0, and I'm not saying A times B equals some number, I'm saying specifically 0. If A times B equals 0, then what has to be true? Mason.
Either A or B has to is 0.
Either A or B is 0, or how about both? That's a really, did you hear that? Wasn't that a very logical conclusion? If A times B is 0, then like he said, either A or B, or maybe even both have to be 0. So I'll put that up here. So if A times B equals 0 must be true, well, either A equals 0, or B equals 0, or both equals 0. One of those things has to be true, doesn't it? That's one of the special properties of 0, of course, is that any number, any real number times 0 ends up being 0. So we're using that property to help us here, and this is going to allow us to solve some equations. This is called, I'll say it again, this is called the zero factor property. Your book calls it that. We'll often refer to it as the ZFP, right? The zero factor property. And we are going to use this zero factor property to help us solve those quadratics that we've been working with, we've been factoring for a little while. The polynomials in that ax squared plus bx plus c form. So as a little bit of a review, I want you guys to, we'll just go through this together. Would you guys look at those 5 expressions and let's decide which of them are factored and which of them are not. I'm going to give you guys 60 seconds and I want you just to, but next to each one of those, I want you to write factored or not. Okay? So decide which one or ones of those are in factored form. So somebody has gone ahead of you and they factored it, or in some cases they have not. Factored or not. It might not be surprising to hear, but in order to use the zero factor, I'll say it again, zero factor property, you have to have a factored polynomial. It's got to be in factored form. So that's why we're looking at this. Okay, so the very first one, upper left, factored form or not? Not is correct. Bray, what did you have for the next one over? Factored or not?
The next one over?
To the right, yeah.
Not.
Not?
The next one over.
So look at the screen. Look at the screen. Let's just be clear about the one we're talking about. The one that I just circled in gray. Factored or not? Not? Okay. Do you guys agree with that? You think it is factored? It is factored. Yeah, notice how that x has been factored out. And all I'm really leaning on here is that we've done a bunch of factoring over the last week and a half or so. I'd want you to recognize that, for instance, let me show you this. The first one, what's in common on the first one? The one that's not factored right now? There's an x in common. So would you guys agree with me that this is now in factored form? I factored the x out. Okay? So maybe you can see how that one that I circled in gray is in factored form. Somebody has factored the x out. Somebody already did it. So basically that's the question. Is like, did somebody already factor it, or do we still need to factor it?
Oh, that's the question.
So then how about the third one, the one that I am circling in red? Factored or not? Hearing a lot of nots. Do we agree on that?
Yes.
If you said not, you were totally correct. Totally correct. There's one symbol in there that makes it not factored. Do you know what symbol that is? That plus sign. Yeah, that's right. If this plus sign was a different sign, like multiplication, it would be factored. But as it stands, it's not. How about the lower left? Is that lower left factored? No. Correct. Yeah, those of you that said no, you're correct. It's not been factored. Do you see how that's the kind of thing that we have factored in the last week or so? All right, and how about the lower right, factored or not? Yeah. It is, yeah, that one is definitely factored. Again, I'm relying on the fact that we've done a bunch of factoring, and you can see that this has been transformed into a multiplication problem. Okay. So I said this before, and I'll say it again, because this is kind of day one of this. You are, and I don't use this lightly. I do mean this seriously. Listen now, you're going to want to focus in. I think you are out of your mind if you think you can be halfway engaged and get this. Like if you're distracted, it's not going to go well. If you're fully engaged, I think it could go quite well. Okay, so let's continue that. Look at number one. Let's continue that same exercise. Is number one, has somebody already gone through and factored it, or do we need to still factor it? Somebody's done it for us, haven't they?
Yes.
Isn't it, do you see how it's a binomial in parentheses times another binomial in parentheses? That tells me somebody has already gone through for me and they've factored it before I even got here. That make sense? Okay, so this says solve. So do this one with me. Write this out. You'll get your chance to do some of these on your own over the next several days. Okay, so if I'm going to solve this, I want to notice that I've got a factored form equal to 0. Okay, it's factored and it equals 0. So do you see how this is a lot like A times B equals 0? You see it up there? Look, I've got an A factor times a B factor and it equals 0. So to use what Mason said, logically, doesn't that mean that either one or maybe both of them have to equal 0? So here's how we do this. I'm going to use the zero factor property. The zero factor property would tell me that I can set each one of those factors equal to 0. Right? Like Mason said, if I've got something times something and it equals 0, then wouldn't one or both of those factors have to equal 0? It's the only logical way, right? Because anything times 0 is
0.
So either one or both of them are 0. Once I've gotten to this point, I simply solve. So I would add 5 and then divide by 2, and then I would subtract 3, and I would get 2 solutions to this equation. What do you think? Any questions? Wait, what? I thought. Yeah, Mason.
I feel like the first box has to be 0.
The first box has to be 0.
The second box makes sense. That's
Okay, hold on. So are you talking about my red boxes?
yeah.
So you're saying the first box, are you saying that it should be x equals 0?
Yeah.
Because you just said the first box is 0. So let's check this out. So Mason is proposing that one of these answers should be 0. Guys, this is going to be super crucial that you see this. If I think that I've got a solution to an equation, like 0, right? How could I check to see if that really is the answer or maybe not? Plug it back in. So I should be able to take this. I should be able to come over here and check by plugging in a 0. So check this out. It would be 2 times 0 minus 5 times 0 plus 3 equals 0. So notice how I've taken Mason's proposed answer and I've simply plugged it in where I see an x. Let's keep going. What's 2 times 0?
0.
What's 0 minus 5? Of course, 0 plus 3 is 3. What's negative 5 times 3? Mason, I'm sorry. We've just proven that 0 is not an answer for this one. Shouldn't I be able to do this and come up with like 0 equals 0 or 10 equals 10 or whatever it happens to be? I should be able to check it and see. So your instincts might tell you, hey, I think one of the answers ought to be 0, but we should be able to prove conclusively that it either is or isn't by doing what I just did. If you were to take x equals 5 halves or x equals negative 3 and plug it in, you would get that. So let's check one of these real quick, maybe even both of them. Hold on. Can I try to prove it to you?
Yeah.
Again, all I'm doing here is I'm trying to appeal to your logic. I'm not trying to get you to memorize anything. I'm not even really asking you to take anything based on faith. All I'm asking you to do is think logically. So do you see how I've plugged in the 5 halves? What happens with the 2 times 5 halves right here? Come on.
2 over 1.
Yeah, 2 over 1, I agree. And then what happens when I write 2 over 1?
Cross cancel.
Cross cancel the 2's, or 10 over 2, which is the same thing as 5. Okay, so I get 5 minus 5 times 5 halves plus 3, which Bray is right. Don't I get 0 times? And you know what? Even if you're not feeling like adding up those fractions, does it even really matter? What's 0 times some number? 0. For some reason I put plus there, sorry. Yeah. So when I do that, I get 0 equals 0. And look, it checked. Just what we were hoping for.
Is that not what I said earlier, though?
Earlier you said, I'll quote you now, you said, shouldn't one of the boxes be 0?
Right.
And I struggled to interpret that. It was just vague.
Can't you plug 3 in?
Let's try it. Shouldn't the negative 3 work as well?
Yeah.
So let's check it out. If I plug in a negative 3, I would get 2 times negative 3 minus 5 times negative 3 plus 3 equals 0. So over here I get negative 6 minus 5. What do I get for that second set of parentheses?
0.
Guys, let me remind you, you are absolutely delusional if you think you can be distracted and sort of halfway pay attention and at the same time get this. Do you see how I end up with 0 equals 0?
Yeah.
Wow, so it checked. So have I proven to you that this way works?
Yeah.
Okay, so let's do one more. And this one will be a little bit more realistic as far as what we're going to be doing. So take a look at, doggone it, let's try number 3. I don't know, I'd love to do 2 and 3, but I think we'll just do 3. So looking at number 3, we'll do our factoring quiz here in a second. This will be a nice segue, that's why I want to do this. So when you look at that equation, has it been factored? You can tell, can't you? Okay, so then what I need to do in order to use the 0 factor property is I've got to factor this. Make sense? So, can you guys identify your A, B, and C? Come on, what's your A?
1.
What's your B? That's right, and your C? Okay, so then my AC is 18. So that goes here. This goes here. This is the same old factoring we've done. Which two numbers multiply to be 18 but add to be negative 11?
Negative 9, negative 2.
There it is, negative 9 and negative 2. It might take you a little longer to get those, but that's okay. Then I use my box. So here is a box. Remember doing this? What should go upper left? What goes lower right? And then what goes in the other two diagonals?
Negative 11 and
Negative 2x and negative 9x, right? We got to get those x's in there because that middle term has an x. And we just scoop out our GCFs. So along the red arrow, what factors out?
Negative 2.
Negative, right? Because remember, if the finishing box is negative, you factor out a negative as well. So negative 2. How about the factoring along the orange arrow?
X.
Only an x, that's correct. How about the factoring along this blue arrow? Remember, the finishing box is negative,
-9.
so it's got to be a negative 9. And then how about along the unmarked
X.
row? Common factor is just x, that's right. Okay, so here's what we do with this. I'd write this as x minus 2 times x minus 9 still equals 0. So at the start it was not factored and now it is. I can use the 0 factor property, right? So let's go back to Mason's original logical statement. If some factor times some other factor is 0, what must be true? One or both of them are 0, right? So what I'm going to do then is I'll set each of those factors equal to 0. This is my 0 factor property step. Setting each factor equal to 0. And of course, for you guys, solving these equations is very easy. X would equal 2, x would equal 9, and both of those numbers work. Therefore, they are both solutions, and I've solved.
That's the solved.
Yep, I've solved. Remember, solving is finding the values of x that make the original equation true.
So the top one wouldn't be the solved one, that would be the solved one.
Yeah, so remember, solved means, like, if you say you solved something and you don't have x equals some number, you haven't solved it yet. So at no point do I have x equals anything until the very bottom in the box, right? At that point, I've got x equals 2, x equals 9. I know what my values of x need to be to make that equation true. That make sense?
Yes.
Do you see how this is also something that maybe we should practice this again tomorrow?
Yes.
And maybe even the day after that? Yeah, we'll definitely do that. All right, clear your desk off, grab some Fort building materials. We're going to do our quiz on factoring. So, like I said, hopefully this has been a nice warm-up for you. So, you guys want to do this quickly so I can get you started on your quizzes. You're allowed to have a calculator. Yes, ma'am.
So this is like zero factor property, this is regular factor?
Yeah.
Oh.
Yep.